Sometimes, on cool, dry days, we get a little shock when we touch a metal object. Static electricity causes this shock. To learn about static electricity, observe some simple demonstrations that show what it does. Perhaps you've rubbed a rubber comb with a woolen cloth. And then attracted bits of paper with it. When the comb and the wool were rubbed together, the friction between them produced static electricity. Friction can produce static electricity. We can produce static electricity by using many different materials. I'll place this page from a newspaper against the wall and rub it with this pencil. The paper is held against the wall by static electricity. I'll rub this balloon against my woolen coat. And when I place it against the wall, it is held in place by static electricity. We say the balloon is charged with static electricity. I can charge this glass rod by rubbing it with silk. I'll charge this rubber balloon by rubbing it with wool. When I bring this charged glass rod near it, the balloon is attracted. Now I'll charge a rubber rod by rubbing it with wool. The rubber rod pushes the balloon away. It is repelling the balloon. The glass rod attracts the balloon. The rubber rod repels it. The charge on the glass rod does not act the same as the charge on the rubber rod. The two charges are different. To see what causes the two kinds of charges, we have to think about atoms. Most of us know that atoms are very tiny, so tiny that there are many millions of atoms in this pencil dot. This model will give us an idea of the parts of an atom. Every atom has a center called a nucleus. In the nucleus are particles called protons and neutrons. Each proton has a positive charge. Around the nucleus are particles called electrons. Each electron has a negative charge. Every atom has two kinds of charges, positive and negative. Usually an atom has the same number of positive charges and negative charges. But when we rub certain materials together, electrons may be lost by one material and gained by the other material. Now let's look at the electrons of this atom. When an atom loses electrons, it no longer has the same number of positive charges and negative charges. There are now more protons than electrons. The atom is positively charged. This atom has gained electrons. It has more negative charges than positive charges. It is negatively charged. Remember that the gain of electrons causes a negative charge. The loss of electrons causes a positive charge. As I rub this glass rod with silk, it loses electrons and becomes positively charged. I'll charge the other glass rod and bring the two of them together. The rods repel each other. Will two rods with the same kind of charge always repel each other? Let's try the same thing with two rubber rods. As I rub each rubber rod, it gains electrons from the wool and becomes negatively charged. The two rubber rods with negative charges repel each other. The two glass rods with positive charges repelled each other. The two rubber rods with negative charges repelled each other. What will happen if I bring together the rubber rod with its negative charge and the glass rod with its positive charge? The two rods attract each other. Let's remember that like charges repel, unlike charges attract. Here are some cereal grains. I'll charge this rubber rod and bring it near the grains. The rod with its negative charge attracts the grains. Why does this happen? We learned that unlike charges attract. But are the cereal grains positively charged? Let's try it with a glass rod, which is positively charged. The grains are attracted to the glass rod, too. We know the cereal grains are made up of atoms with positive and negative charges in them. This rubber rod with a negative charge must be attracting the positive charges in the atoms of cereal. The glass rod with a positive charge must be attracting the negative charges. Like these cereal grains, all matter is made up of atoms which have electrical charges in them. All matter is electrical. If this is true, my body must be electrical too. Let's test to see. First, I'll give this rubber rod a negative charge. It attracts the cereal grains. But now, after I rub the rod against my hand, it does not attract the grains. Some of the electrons from the rod went onto my hand, so the rod is no longer charged. Like all matter, my body is electrical. Is water electrical? I'll let a thin stream of water flow out of this container. Watch the water closely as I bring a charged rubber rod near it. The electrons on the rod are attracting the positive particles in the atoms of water. To produce large charges of static electricity, we can use a machine like this, called an electrostatic generator. Inside the generator, there is a wool-covered roller. As this rubber belt moves over the woolen roller, the charge is produced. The belt carries the charge to the top of the machine, where it collects on the outside of this metal dome. To produce a strong charge, I'll turn the roller quickly with a motor. The charge soon becomes very great. We've seen four important things about static electricity. We saw that friction can produce static electricity. There are positive and negative charges. Like charges repel. Unlike charges attract. And all matter is electrical. Remembering these 4 important ideas will help us as we learn more about static electricity and the way it behaves.